Now, let's look at example 4 that explains the use of remainder theorem. Find the remainder when a 6x squared plus 5x minus 1 is divided by x minus 1. Recall that your remainder theorem is px equal to qx multiplied by dx plus rx. So first step, we need to rewrite your given polynomial and divisor in terms of remainder theorem. So px is 6x squared plus 5x minus 1 equal to q, that is as q, times divisor x minus 1 plus rx. Now, if we look at these equations, we can find remainder if we omit the quotients. So what we would do, we will let the divisor equal to 0 so that we don't need to find the quotients. So let x minus 1 equals to 0, so x equals to 1. Step 2 is to substitute the value of x equals to 1 into these equations. So 6 times 1 square plus 5 times 1 minus 1 equals to qx 1 minus 1 plus rx. Since we know this would become 0, 0 multiplied by anything would become 0. So we don't have to find what is quotients. So when this is 0, you will straight away get the remainder. So compute this, you will get the remainder is 10 equals to the remainder. Now let's try with example B. Find the remainder when 2x cubed minus 3x squared minus 4x plus 1 is divided by x minus 4. Remember, your first step is to rewrite the given informations in terms of remainder theorem. So, your px is 2x cubed minus 3x squared minus 4x plus 1 equal to, your quotient just write is as qx since we don't know what is your quotient, and your divisor is x minus 4 plus rx. Now let's guess what your x should be. Correct, it should be let x minus 4 equals to 0, so x equals to 4. So step 2 is to substitute the value of x equals to 4 into the equations. 3 times 4 square minus 4 times 4 plus 1 equals to, remember in the previous example, we know that this is 0, so you can just write it 0 plus remainder. So now your remainder is, if you compute this one, you will get 65.